Hello, and welcome back to Aggressive Mastery. This is Devlog 4 about Roadless, the Escape from 2027 video game I'm working on. Thanks for all the comments I've seen in the YouTube and also on the different forums I'm working through. And also it's cool to see some of the stuff you guys are working on. What I want to talk about today, and what I'll title this, is about how I've implemented a couple different pieces of vegetation and I'm able to receive 60 plus frames per second in 4K or other resolutions in the DOTS example multiplayer, which is a pretty close to where I want to be for the beginnings of the engine. And so let's take a look at that real quick. And today I get to kind of use all my monitors, which is kind of funny. So yeah, I have a ultra wide sitting over there, an Acer 35p, Z 35p. I have a little 1080p right here, and then the big 4K right here. We're going to be so let's take a look at all these on the same video. So I'm going to go ahead and hide me. Here's let's see what the system is at first. Where am I? This should be wrong screen. There it is. So what we're working with here is a i7 A700K. Now it's overclocked. It says 3.7 because that's what it is, but it's actually running about 4.5. I have 32 gigs of 4133 megahertz RAM. That's nice because that gets me pretty close to a match to my CPU. For disk wise, I have two 512 gig M2 drives in RAID 0. If you put them in RAID 1, they would perform better for all this, but RAID 0 gives me extra storage. I did the testing. It didn't do any better on reads, only better on writes. Did double the performance on writes at actually doing 3.5 gigs on writes. But now actually, anyway, long story short, it's a fast set of hard drives. And then for a GPU, we're looking at the 1080 Ti. Now what you're going to notice about the 1080 Ti, it's currently pegged because I am going to be recording this on this system. I'm also running the engine on two separate executables right now on those on the 4K screen and the ultra wide screen. The ultra wide screen is 3440 by 1440, I believe. Alright, so let's pop over to those views. Go back to the 4K. Right here we have the actual server launched, and here's the 4K screen. I'm on my ultra settings. We'll go through those. There's the my monitor's at 4K resolution is actually sub 4K. We can go ahead and bump it up just to prove. Boop. So this would be the engine actually rendering at 4K. Full screen and with TAA on. We're getting through what I'm doing here is I'm taking time.delta time times or plus the previous time.delta time stored in two variables divided by 2 and then takes 1 divided by that number to give me frames per second. So it's averaged between the last frame and this frame. So I'm getting right at 60. Now what you're seeing is grass on top of grass here. So I have grass textures out to 200 meters, which is a large grass texture, or large grass model we'll look at. And then I have a shader, which we saw from Brackeys, that adds wind to that. I use that same shader to do my bushes, and also to do the leaves on my trees. And that allows for motion on all the plants. And additionally, I also can use that same thing on my billboards way out there to give life to the billboards, which there is, but there's just so small of a motion right now. So let's go ahead and kick this down from ultra to low, and you can see the frames will go up well above 60. Now, who's this person, right? Let's go look at that screen. Let's look again at the GPU is pegged, CPU. What's going on there? Room for use. What this tells me, since I'm actually running two versions of this game, there's the other version. Let's go ahead and bring that up on OBS. Oh, this isn't going to work. Well, anyway, I'm running another screen over here that's actually playing them. So let's go ahead. I'll just put you back on the first 4K screen, and then I'll drag it over. There we go. Now I know what to do. It's the main screen. Here's the ultra wide view, and what you can see here is that it's getting 80 frames in the ultra wide, while also running the server and also a full screened 80 frames per second. So let's just unfull screen it. So here I'm running two versions of the game at great frames on a 1080 Ti with great foliage on high with TAA. And let's go look at what it looks like in the editor. Oh yeah, and the editor's running too. Now this is not the game we're playing in. I'm not using Live Link. I'm not interested in all that jazz at the moment. Boom. Let's actually hit play in the editor. So right now I have the game running as a server. Oh, look at that. The editor joined into my dedicated server instead of the editor server. This is delicious because we can see what's going on now in the actual. So the editor just joined our dedicated server, and the editor is running in 4K as well. Let's go ahead and turn that down just because. See, I think it's locked to something here. Anyway, let's look at occlusion culling. What we're seeing in the scene. This is what we're seeing. Here's our player. A little bit behind them's drawn, and then everything in front of them's drawn. As our player looks away, you can see everything disappears, including the other player, as our player is now facing where our editor camera is. And so you can see Vegetation Studio's full stream culling in action. You can also see the terrain's occlusion culling action, which is how the terrain disappears. As I look straight down, everything disappears. As I look at the player renders. Ah, victory. Hey, new player. So, using Vegetation Studio, I went ahead and it uses jobs and the ECS and DOTS itself, so it's a beautiful thing to add into this project. It works well. He has the needed plugins, which I'll show you that. So let's look at this basic graph here. You can just get a custom node, this one right here, the VS Pro HD Instance-Indirect node. That will allow you to do Instance-Indirect in HDRP, and that will give you much better performance. Let's actually, and not to go into that detail, I think this video is pretty long already at about 10 minutes. I mainly wanted to show how we were able to get there, and I'm going to close these out and show the visual quality. And so let's go back to the editor, and we're going to look at that real quick. Hit play. Scene. So where's our player? Player's right here somewhere. Oh, falling from the sky. They're standing on top of some grass. Let's go ahead and turn on wireframe. You can see what type of things are shown. lots of grass. This grass also does LOD out, so I have it turned to just the grass tips out here. So I do run LODs on the trees, grass, and shrubs that are within the, and that's a key piece, within the vegetation realm, not the billboard realm. Billboards, I remove any type of LODs from the billboard and use the renderer itself to do a distance cutaway or culling or zeroing of the model or rendering when it gets too close to the player, and I'll show you that. So right now with the player where he is, turn shading back on, what we have is our trees that do different levels of details out to about 200 meters. Then at 200 meters we have our billboards that take over. In the next video I'm going to be replacing those billboards with better looking billboards, and then it should be indistinguishable, the transition, which then we'll have the full engine done, and we can see how close we can get the billboards to the player. When you go out here to right where that transition happens, you can see our bushes disappear. So this at this area right here, if I take my player and move them forward, you can see bushes up here, and the trees get more detailed. Or if I back it up, they disappear because they're not visible, or the detail, I'm not giving out that distance. Now, as the camera, what's happening is I'm using that shader. You can see the trees are disappearing from the camera because the shader sees the camera as the player. So it's kind of cool to show the effect here. You can see the trees, the polygons of the trees shrink in towards the middle, and that's using in the shader. I made this custom piece up here. Hey, come on, go. I took the camera position and the position of the renderer in absolute world. I ran a distance node between the two, put that output to a comparison. I have a variable here just to say, hey, at what distance do you want to call 200? So at 200 meters, if 200 meters is larger than the current distance to the camera, go ahead and move or multiply our transforms times 0 on their x and z, but leave their y's at 1. And then I put a branch here. This branch takes your output of the comparison, so it says, hey, is 200 meters greater than the distance? If that's true, it will come into the branch and the predication here and say that's true, and then you'll get the true statement will pass through this logic gate rather than the false. So if it's true, I'm taking the Vegetation Studio's Instance-Indirect transform information and times it times 0 so that the renderer shrinks in the middle and you can't see it. This way the billboard disappears, but I don't actually run LOD on the billboard, the logic. And you see it in the scene happening here as the trees are disappearing as I try to get close to them with the editor camera. Although these trees aren't, because they're rendered in a different way with a different shader. Or rather, the shader doesn't have that culling turned on. And so then in VegStudio, my biomes, you'll see that I have trees are just the billboards, and those are everywhere. They're Instance-Indirect and they're everywhere. But using the renderer, the script or the shader here, when you get close to the trees, they disappear. And that enables me to use Vegetation Studio's grass plane culling, basically, at 200 meters, to be where it renders grass, and then it stops. And that gets our performance up real high. If I'm going to do some testing to make sure this is still valid, because this was giving me a 20% boost versus just running your regular pre-baked LODs in the FPS sample. And 20% makes or breaks you. I mean, it makes or breaks me. I mean, to have a 20% performance game I'm not capturing, I mean, I could make 20% more logic in my game. So I got to capture that. I can't leave that on the table. So that's why Instance-Indirect is so important, because that gives you a 10 to 20% boost in frames itself from how it can run on the GPU if you can get that done on entities like this. So that's why we're getting such great performance, is using Instance-Indirect on all these prefabs and models, getting rid of any of the logic for LOD by using the shaders to do it on the GPU, and combining meshes is really important as well. So that's one more thing. So where you're getting a whole bunch of triangles is on the very close grass, this dense grass right here. If we go to wireframe on it, there's just a whole bunch of little pieces of grass, right? If you did that all as individual models, this will crash. What you want to do is bake it into as big of a mesh as it makes sense for all of your objects. So I may even bake little scenes, bushes of trees and stuff into one mesh and then put those randomly in the world, because that should render quicker than the individual trees and stuff. But culling will come into effect because you would cull the whole object rather than be able to cull just small pieces of individual ones. So I'll probably be testing all that stuff. You know, we could probably do VegStudio live here. So let's see. But it's so hard to see. Oh, let's remove the grass. So this is to give you one more view, and I mean the grass textures. Here's my grass model. You can see I actually have a pretty large grass patch, because I think that's about as big as I want to deal with, because you do have issues on the outside of how large of a patch this is, that if the terrain moves, this will fall off of it and look bad. So you got to manage that by where you put your models. And then ultimately in Map Magic, let's go ahead and get rid of the terrain so that we can give you a really good view of how many meshes we have in here. It's an annoying thing to do. Okay, so I removed the texture, and now our model should really stand out. Where the grass is, where the bushes are, where the dense grass is, where the LOD happens. Let's make this big. And where all the trees are. And you saw how this was running at 4K, at ultra wide, with both those executables running with the server, and also recording this video with the full-time screen up, which we can go back to as well. But so yeah, this runs pretty well. I know that. Let's go back to me. Thanks for hanging out. This one's a little bit longer at 17 minutes, but you know, it's fun to show how performant DOT seems to be. Now what I mean by that is that Vegetation Studio and how the rendering's doing and the HDRP stuff's going, that's great. But to know I'm also having the network connect to each other and communicate in a quick way while that's happening on this one system running 3 screens and having the CPU still not be touched means there's considerable distance inside of that package to add more players, to add more frames per second, more detail, and also to add more game logic like AI and inventory stuff. Because that's all what gets to go in that extra 70% of my CPU that's not being used, is all that. So I have 70% of this one system to throw at all the rest of the game logic now. Oh, doesn't that just sound amazing? Oh, thank you, Unity. Alright, I'll see you guys next time. Thanks for hanging out. Ciao.